Well, it's nearly 3 o'clock, so I think we will begin. And I would like to welcome everyone to the 5th webinar hosted by Rulmeca Corporation. Our plan is that you will find the next 60 minutes useful. We've prepared information both of a commercial and a technical nature that we think will help you do your job more effectively going forward, whether you be a salesperson or a conveyor operator or a conveyor engineer of some sort. We have something we think for everyone. I'm your host, Mike Gowitsky, and I will be joined by two co-presenters, Brian Vrablich and Steve Forbes, both here at Rulmeca Corporation's facility in Wilmington, North Carolina. Let me shut off my webcam, since you know what I look like now, and we can use the full screen mode. Welcome to what we're calling the MOOC midterm of the Rulmeca Corporation Conveyor Drive University. MOOC stands for Massive Open Online Course. We prepared this thing several months back as an aid to folks faced with the challenge of working from home. It's not exactly a replacement for the 2-day-and-a-half seminars we had planned to hold in Wilmington, North Carolina, but it's the best we can do, and we put some effort into it, and I hope that those that have participated in the first semester found it useful. The host of this webinar is Rulmeca Corporation. We're situated here in Wilmington, North Carolina. We're a major supplier of motorized pulleys for the U.S. materials handling market. We were founded in 2003. As I said previously, the presenters will be Brian Vrablich, Stephen Forbes, and myself. And I draw your attention to the fact that we are in webinar mode, which unfortunately means you will not be able to use your microphone or your webcam. However, you can use your chat feature throughout the entire presentation. Steve and Brian are standing by. If you ask a question 5 seconds from now, they will be sure to answer you real time via chat. And Brian and Steve will also make sure that at the end of the conference, while we take 5 to 10 minutes, we'll review the key questions that they think everyone would get a benefit from exploring. Today's conference is attended by nearly 100 people from throughout the United States and Canada and various places all over the world, including the Caribbean and Europe, to name a few. I think we have some folks even joining us from Asia. Our collection of participants include industrial distributors, sales representatives, equipment manufacturers, some end users at chemical processing plants and food processors, as well as several Rulmeca affiliates. And we welcome all of you and plan to give you a useful information in the next 60 minutes. Now, we realize, because we've looked at the forums, that some of you folks have taken the MOOC. You've actually listened to 6 hours of videos and taken the 6 quiz modules that we prepared. Having reviewed them, I can say that everyone gets an A+. Seriously, you did very well on the quizzes that you submitted. We've excerpted information from those quizzes that we think will be generally useful to everyone. However, we realize that most people in today's webinar have not sat through 6 hours of videos and taken the quizzes, so you'll be seeing some things for the first time. And finally, we realize that some of today's participants have actually sat through a day-and-a-half of training here at Wilmington, North Carolina, and we are aware of the fact that you know a lot of this stuff already. However, we've added things to today's webinar that we think you will find useful as well. Rulmeca Corporation is part of the international group called the Rulmeca Group. We're situated in 24 countries around the world. We have 1,200 employees. And we are a major supplier of rollers, motorized pulleys, and components for the global materials handling market. We're privately held, and we celebrated our 50th anniversary in 2012. Give you an idea of how long we've been at it. What you're looking at right now is the slide that depicts assembly and local assembly centers around the Rulmeca world. Our main production plant is in Aschersleben, Germany. And we also have other assembly plants or local assembly plants in Canada, the US, Poland, Denmark, UK, Spain, Italy, India, and Thailand. Here's today's agenda. In addition to going through the 6 modules of the first seminar, I would like to give you some Rulmeca Corporation RMP news, Rulmeca Motorized Pulley news, and then we will conclude with highlighted questions that you'll submit. Here's the news, 6 items. I will give you an update on our COVID safety, give you an update on our Google and YouTube work, give you an introduction to some of the special capabilities that we now have, show you a trend on our unit handling motorized pulleys, discuss new equipment and inventory, and also tell you a little bit about power calculation software that has been improved. We shut the facility down to administrative personnel on March the 31st, keeping open only the production staff. They did a great job. In fact, they broke a production record by 26% in May, but all of the administration, sales, and marketing people joined our production guys on August the 31st. So now we're all here at our Wilmington facility, and we will continue to make the online consulting and training available, even though we're here in the building. We realize that some people are still working from home, and many of the customers that we serve have safety restrictions for obvious reasons. Here's a quick update on digital marketing, if you want to call it. Our YouTube training videos have continued in popularity. Our most popular one now has over 30,000 views. We have more than 1,000 subscribers, and we've nearly logged, we're probably 3 days away from logging 4,000 watch hours. We're happy about all that stuff, and mainly because it's providing information to folks who need it around the world 24/7. When we're sleeping, the videos are still talking, if that's convenient for you. We now have 84 training videos and 20 playlists, 11 of which were created specifically for the MOOC, the course. I would like to talk for a second about our 3D CAD capabilities. We are able to help our customers develop things such as this unusual motorized pulley with fins attached. It uses 316 stainless steel components at the request of the customer we were serving. You can see the CAD model on the left and the actual unit on the right on our test bench. This was used in some manner in the processing of broccoli. Here's a quick highlight of the trending that we're excited to share with you. The year-end estimate for 2020 is pretty accurate, we think. We have a backlog that has helped us guess how the year will end. And you can see in these colors how the small motorized pulley models are trending upward dramatically, specifically as we supply motorized pulleys to the food processing and package handling markets. Note in particular the lime green one. That's our 4.5-inch diameter unit made in Rulmeca, Germany, and also made here. And the purple shaded area represents our 5.5-inch diameter model. And last but not least, notice the blue at the very bottom. This is our 3.15-inch model, which are trending upwards quite nicely. And that's a neat segue to what we've been doing here lately. In 2 weeks, we will receive another CNC lathe. You can see it pictured on the left. That will automate the production of shafts here. That will help us respond to customers with orders that are larger in number. And on the right, you just see a picture I took a couple of hours ago to show you some parts in stock. We have permission from the holding company to increase our inventory by the end of this year, particularly in small motorized pulley parts, in order to enable us to capture larger orders. Whereas for some years we were able to do onesie-twosies pretty quickly, now we're challenged with plenty of opportunities to do 10sies and 12sies, and we're preparing ourselves to do just that. Now I draw your attention to a news item which pertains to calculating power in conveyor belts. The old Microsoft Excel program, which was written back in the 90s, which we've used until very recently, has been superseded by a free cloud-based online version, which is based on the latest SEMA edition of conveyor drive power methodology, as well as DIN for the European users of it. And it's available not only in imperial units of measure, but also metric. You can find it on our website, linked as you see there. Here is a summary of the 6 components of the first semester, which we will be discussing. First, we have the introductory material. And for those of you that aren't familiar with the spreadsheet in the back, it shows the duration of each video and gives hyperlinks to the individual videos, as well as a playlist for each of the 6 modules and a hyperlink to the quiz. So we'll be discussing segments of each of these things, including the introduction, selling, marketing, and philosophy, conveyor drive technology, your sales and marketing resources, 4 conveyor problems and a testimonial, and finally some how-to highlights from our short segmented videos. Let's look at the introductory material. As those of you already know who have seen the video, we highlight the fact that we offer the Rulmeca Advantage. And what is that? Well, the Rulmeca Advantage is rolling up our sleeves and partnering with our customers to solve their conveyor problems, no matter what it takes. And as I hope you'll see in the next hour, we're serious when we say just that. The webinar, which we did some months back, helped viewers resolve 6 conveyor drive issues, namely reliability, maintainability, safety, space or weight problems, belt slippage problems, and inadequate power problems. You have before you a picture of an example of an exposed drive system, in fact, 2 exposed drive systems in a very, very corrosive solar salt mine environment. Let's talk about what is the potential solution, or how is the motorized pulley a potential solution to those 6 things that I mentioned previously. Well, it's a potential solution because the motorized pulley concept offers a conveyor drive package which is hermetically sealed, internally powered, and self-lubricating. As you can see pictured before you, the motor bearings, the gearbox, gears, and bearings, and the main bearings are all enclosed within a hermetically sealed shell. And that is the secret of success. We protect the important components from harsh elements. This cross-section allows us to show the basic elements, namely the stator, which is shown in orange in color, the rotor, which of course rotates within the stator and is directly coupled to the gearbox, also pictured here in yellow. These 2 components, the motor and the gearbox, are enclosed and protected. We attach drip lips to the inner surface of the pulley shell so that oil can be circulated. And that oil serves 2 purposes. The obvious one is lubrication of all mechanical components, and the less obvious one is its usage as a heat transfer medium to get heat from the hot stator transferred to the pulley shell so that heat can be dissipated through the shell and into the belt, which we use as an infinite heat sink. This is a new slide we put together fairly recently, and you can see the number of bearings and the number of gears which are all protected through this hermetically sealed, automatically lubricated drive system. There can be as many as 4 gearbox bearings or 3 gear pairs, as you can see pictured here. The drip lips act like a water wheel to constantly pour oil onto the stator and splash it through the inner workings. And most people nowadays specify synthetic oil, which is good for 50,000 hours of operation. And for those of you who may be new to the motorized pulley idea, We've been doing this since the early 1950s. This is old technology, which we constantly improve, but the idea has been around for a long time. Here's a way that the motorized pulley can enhance safety or improve safety. I took this picture at a power plant in the UK a few years back. In the upper center, you can see an exposed drive system, which was originally mounted above the chute, which transferred coal into these deep bunkers. A maintenance man was maintaining this thing, and unfortunately, a weld broke on the handrail, and he could have fallen to his death in one of these bunkers, but fortunately for him, it had just been filled with coal. He wasn't hurt, but of course, plant personnel took careful attention to the fact that the exposed drive system, which was getting long in the tooth, needed to be taken care of, and their idea was to install a motorized pulley, which of course, in a sense, is self-maintaining. These are new slides for us. For those of you that have seen some of these presentations in the back, they help us to illustrate that the fact that the motorized pulley centers the weight between the two support beams, it enables manufacturers of conveyors to use lighter structure than otherwise might be possible. Because it sits between the beam, there is no overhung load. The weight is supported more or less evenly between the two beams of the conveyor. And also because the torque is transferred through the dead shaft and into the structure, we avoid the racking action, which is very common, particularly on flexible conveyors. And in addition to the obvious reason why a motorized pulley is compact, because the parts are on the inside, the less obvious thing is that motorized pulleys in general are 33%, approximately 30% lighter in weight than an exposed drive system. There's no cast iron enclosure required for the motor. There's no cast iron enclosure required for the gearbox because we use the pulley shell as an enclosure. And so we eliminate that quote, quote, redundant part. We also do not have a through shaft, but rather we have two small stub shafts because we use the drivetrain as an enormous deep beam to resist the weight of the conveyor belt as it presses tension on the pulley surface. This is an example of a mine in Wyoming, which was encountering slippage problems. It happens to be a trona mine, and trona, when it gets wet, it's like detergent. It makes everything very slippery, including the surface between the drive pulley and the bottom of the belt. Well, on the left, you can see the 30-year-old 100 horsepower drive that was originally installed. And on the right, you see a picture which shows where the motorized pulley was installed. This was an easy installation. The pulley was actually put into the existing mechanical take-up at the tip. So the installation was relatively simple because it only required running electricity to the boom tip and 4 bolts. You might also be surprised to know that the pulley, the motorized pulley, 50 horsepower, 60 horsepower, weighed 2,400 pounds, and the original pulley, which was non-driven, weighed 3,400 pounds. So this retrofit to eliminate slippage was relatively straightforward. In addition, this customer added more power to the conveyor. This photo shows a walnut processing facility in California who had just upgraded their main transfer conveyor. On the right, you can see the conveyor, which was less than 6 months old. They had problems with slippage whenever it rained because it was a single drive driven from the head. The straightforward fix was to convert it to a dual drive. You can see one of our distributors taking a look at the tail section and taking measurements so that a motorized pulley could be fit into the tail. So the retrofit was eliminate the exposed drive at the head, replacing it with drives at the head and the tail. Slippage was solved cold. This is another example of a conversion from a single drive at the head to a dual drive at the head and tail. This customer had a problem with inadequate power at startup, and that's what prompted the call to Rulmeca Corporation. And our calculations showed that the original 75 horsepower was inadequate, so we recommended converting to two 50 horsepower units, one at the head and one at the tail. That was done. And the customer not only was satisfied that extra power solved the startup problem that was occurring, but it gave a side benefit as well. It eliminated a belt bouncing problem, which occurred every time the conveyor was started up empty. So installing a drive at the head and a drive at the tail not only afforded more power, but also handled the belt tensions in such a way that problematic belt bouncing was eliminated. And it wasn't just a noise that the bounce was making. The bouncing was actually causing damage to the belt occasionally, and sometimes damage to the feeder support structure as well, all completely eliminated now. Let's have a look now at module number 302, which addresses marketing philosophy and strategy, if you will. Our company is committed, and this webinar is one example, of our commitment to training salespeople to be subject matter experts. We need to be able to help users and designers of conveyors to optimize what they have. And we spend a lot of time doing that, writing papers, making videos nowadays, putting information on our website. When possible, pre-COVID and post-COVID, we do on-site training. We also are committed to using our selective independent distribution network, and thank you to everyone who has tuned in from all over the United States, from the East Coast through the Midwest and all to the West. Thank you for listening in. And those of you that are relatively new to the motorized pulley marketing idea, welcome aboard. We're also committed to an extensive network of local service providers. We have more than 5 dozen scattered around the United States. We're also committed to a trained and motivated independent sales representative network. And thanks to the 15 or 20 of you folks who were willing to commit to an hour today, thanks for being here. Part of our philosophy is always looking for Bob. We're looking for old, busy facilities which have conveyors who could benefit from this technology. And often, Bob doesn't know the technology exists. And I hate to sound a little preachy, but in Rulmeca Corporation, we answer the phone. The phone does not ring in this company 3 times. We're very committed to that. And of course, we promptly respond to emails and text messages, of course. And we, as you'll see in a minute, handle aftermarket service and warranty work in a very liberal manner. This is a quick glimpse at the independent distributors and service centers around the country. Always looking to add more in areas where we have no coverage. Here's an example of aftermarket service work. This end user installed 9 of our large motorized pulleys, 100 horsepower or larger, on 3 bucket wheels. And they did a refurb after 10 years of service. And during the refurbishment, there were some problems that were encountered. And so Rulmeca Germany, our sister company, as well as us and our local distributor, Jasper, partnered to help this customer make his 10-year refurbishment, shall I say, like new. And we honored the warranty even though it had expired many, many years prior. That's kind of our attitude. Let's take a look at some additional items in Module 302. How would a salesperson overcome the statement that your price is too high? Your motorized pulley drive is a premium compared to the way I've been doing it for 10 years. Why should I consider spending more money? Well, we suggest that end users consider the fact that downtime is expensive and exposed drive systems can break down since they're less protected than motorized pulleys are. And even though the individual cost of the components might be less at the outset, it's important to remember that all of the parts need to be stocked. And That's an important consideration. And of course, we always suggest that operators think of what downtime costs. Is it $10,000 an hour, $50,000 an hour, some huge amount of dollars per hour? If that's the case, then the premium price for a product which is more reliable could actually offer the lowest total cost of ownership. Sometimes we hear as we make presentations that we're apprehensive about this new technology. Well, as I said previously, we started making them in the early 50s. And there are hundreds of thousands of large motorized pulleys in service throughout North America and the world, and literally millions, no kidding, millions of small motorized pulleys in service in North America and around the world. And believe it or not, motorized pulleys in excess of 50 years old are still working. Let's turn our attention now to some topics on the subject of conveyor drive technology, particularly belt tension. We have one full video that explains how to calculate TE, which you see pictured on the upper right-hand corner. It's essential to know TE, or effective tension, in order to be able to figure out how much power is required to move the conveyor belt. In addition to calculating TE, and we have programs to do that, you can do it yourself or you can ask us for assistance. It's essential to calculate T2, and T2 is the tension required to prevent slippage on the pulley face, and T2 is also that tension required to prevent sag in the least tension, the lowest tension area of the belt. So we help with that stuff. Our videos covered a tutorial on force work and power, very basic rudimentary thing, 30 minutes of that. We also presented a video on how asynchronous three-phase motors work, and I really draw your attention to that if you haven't already seen it. It takes the mystery out of it. And we put together both unit handling and bulk handling short videos, and all of these things have explained in as simple a manner as possible how to go about calculating required belt pull, and therefore how to calculate required belt power. We won't go into this equation, but this is the equation we've used for more than 20 years. It's called the historical method developed by SEMA, now superseded by the universal method in the new program I mentioned, which has just come online within the last few months. But we've used this equation to develop the tension required to overcome friction and gravity and momentum. And the takeaway for all of you folks who are hearing some of this for the first time is this. Let me simplify all of these numbers and letters by saying belt power, which is required to move a conveyor belt, is simply the product of the effective tension in pounds, in imperial units, multiplied by the required belt speed in feet per minute. Pounds times feet per minute gives you the power. And we know in imperial units that 33,000 foot-pounds per minute equals 1 horsepower. So if you know the number of pounds you need to pull on the belt with and the feet per minute you need, then you, by definition, know the power. And in metric units, we know that 1 kilowatt equals 1,000 Newton meters per second. So if you know the number of newtons to drive your belt and your belt speed in meters per second, you can certainly calculate the required kilowatts. Now, here are some resources for both sales and marketing personnel, as well as end users and designers and so forth. This is a screenshot I took of our website. You can see on the website the place where you would, the hyperlink where you would click to get the power calculation programs, of which there are 4. Also, we have plenty of catalogs and brochures, as you would expect. And since about 6 months ago, we've been using a new online chat service. And Brian, are you able to add some comment on that chat service? I guess we were surprised to see how much usage it was getting, right?
Yeah, we get a fair number of users per month, some handful. We noticed kind of a trend, and some of our customers and some of our vendors and some of our colleagues in this realm, this conveyor design world, were using this technology. It's inexpensive to use, it's easy to use, so we put it on our website just to check, and it's good. A lot of people who may or may not have the time to send emails and they just want a quick answer, or they just want a quick reach out, it's an easy way to reach out to us. We generally man it from 8 to 5, and then afterwards it's basically an email service. So if you get to us after 5 o'clock Eastern, it'll send an email and one of us will respond first in the morning, or maybe even that evening.
I guess it depends on the urgency of the email. It's interesting once you get to be a little bit long in the tooth like me. It's interesting to see the way technology changes. Back years ago, it seemed like faxes became the thing to do, and nowadays we rarely get documentation via fax. And we're almost every day we're surprised by some new communication medium. This chat service is something that Brian said is being used on a regular basis. Of course, we use emails and phones, and now we're finding that people are communicating with us, believe it or not, through various portals. For example, our YouTube channel is a place where, I don't know what you can call it. I guess you call it chatting. So we use whatever vehicle seems to be most user-friendly, and this chat feature on the website is one of them. Continuing on with resources that are available in the downloadable format are our online application data sheets, both for bulk and unit, our online ordering forms for bulk and unit, as well as, of course, brochures and flyers and technical papers and that sort of a thing. Now, I want to toot our horn on this YouTube channel because we have been amazed at how many people have apparently seen it to be a benefit. Now we have 84 videos all told, 20 playlists. As I mentioned previously, 11 were created for the online course that we're having a midterm for right now, so-called midterm. We have over 1,000 subscribers and more than 4,000 annual watch hours. We've developed a playlist in such a way that if somebody wants information, they can select the appropriate playlist, whether it would be something of a technical nature or something of a commercial nature. That's all there for your viewing pleasure. And by the way, let me be quick to mention that this webinar is being recorded and will be posted by the end of business today. So all four of our previous webinars have been uploaded to the YouTube channel, and the 6 work from home videos that we prepared during the work from home time between the end of March and the end of August, those are all there as well. The webinars are about an hour, and the work from home discussions are about 5 to 10 minutes apiece. Let's turn our attention now to the 5th module in our first semester. In that 5th module, we went through drive motor burnout, excessive hopper feeder pressure, excessive skirt board drag, and excessive belt cleaner drag. Now, I'm going to skip discussion on hopper feeder pressure, skirt board, and belt cleaners because we'll go through that in more detail, let's call it in the final, on December the 9th, when we have our next webinar following the 2nd semester, because the videos go into more detail. So we'll skip that for now. However, we will spend some time looking at the topic of drive motor burnout because it's a pretty important topic, and this is a great place to cover it, if you will. Why do conveyor problems occur? Well, sometimes the wrong equipment is installed. That's pretty obvious. You shouldn't do that. But more often than not, correct equipment is installed, but something has changed. Maybe this is obvious to everyone in this webinar. Maybe there's some people that haven't thought of it this way, but the correct equipment may have been installed, but something such as conveyor handling rate may have changed. Maybe production pressure to go from, say, 400 tons per hour to 800 has put a strain on something, causing what was adequate power to be inadequate. Or something more subtle, such as material may have changed. A system originally developed to move wood chips may have been divested and sold to another facility who is now handling iron ore. The change in material may change the characteristics or change the behavior of the material being used, and therefore be problematic to some of the original equipment, such as the motor or the gearbox. Ambient conditions may have changed. A system developed for lower temperatures may be in service in higher temperatures, or vice versa. Something that was moved from one plant to another, with the second plant being in a more tropical environment, the humidity may be causing problems, whereas previously there were none. And last but not least, I know it's obvious, but I'm going to say it anyway, conveyor parameters, when they change, have a dramatic impact sometimes on the drive mechanism. If the conveyor is twice as long as it used to be, 10 horsepower or 50 horsepower might not be enough. Here's a more subtle thing. Belt carryback is a problem everywhere, at least in the bulk world. Well, even food processing, belt carryback can be a problem. And if one belt cleaner is good, maybe 2 or 3 or 6 is better. Well, they may clean the belt, but there is a price to be paid. And we'll be talking about that in more detail in the second semester, because a cleaner puts drag on the belt and therefore requires more power. It's possible that belt speed may have changed. It's possible that a skirt board system could have been modified, or the power supply itself might have been modified. Now, it's very important when talking about motor problems, so-called. Is it minor or is it major? Is the motor tripping or is the motor burning out? Because if the motor is tripping, it might be a simple problem of a simple matter of making an adjustment and stopping the tripping. If the motor is burning, and tripping may cause a problem for 5 minutes. Fix the problem and you're back up. A motor burnout would take however long it would take to swap out the motor, or you have a major conveyor drive mechanical failure. So we have small and we have large problems, and any one of them should be addressed. We'll be talking about burnout now. Common causes of burnout are too much current, maybe that's obvious. That is the far overwhelmingly most important reason for motor burnout. Too much current, which means too much heat. Other reasons for burnout would be wrong voltage or unbalanced phases, less common. It would be important to avoid electrical causes to burnout in your supply voltage. Of course, you want to eliminate any voltage surge. You can't have, it's necessary to protect your building as best you can from lightning strikes. Sometimes it gets through anyway. A voltage surge, which would be a problem with a resonance-induced frequency on a line connecting a VFD to a motor, that could be avoided by filtering. So things like that can be done. Imbalanced phases is another problem, less common, but also there. How to avoid mechanical causes? You check for required, you should check the required power, and you should check for extra drag, as I mentioned previously. And last but not least, how should you protect motors? You should verify your overcurrent setting is correct. You should use thermal protection, if any, and we're pretty fussy about that. We certainly recommend to all of our customers to use thermal protection in addition to overcurrent protection, which I'll explain in a minute. And when all else fails, if you find that for whatever reason your power is inadequate, then by all means install a more powerful motor. Or in the case of a motorized pulley, install a second drive to the belt. Here's what a motor which has burned out looks like. You'll see it's a uniform burn. Other types of failure have different characteristics, but this black motor is one that has been overloaded. And in actual fact, this motor was not protected from overload. You may or may not be aware that an AC three-phase squirrel cage induction motor will self-destruct itself. It cannot protect itself from overload. In other words, if you install a 10 horsepower and yet you put so much material on the conveyor that the drive is required to give you 20 horsepower, it will attempt to suck current out of the wall and provide 20 horsepower, even though it's internally designed to only handle the heat, which matches to 10 horsepower. Here's an example of a motor starter which has a variable overcurrent switch. So this overcurrent setting can be at 4 amps or 5 amps or 6. This one happens to be set at 4 amps. If the motor is put in service and it trips, and every other day the person has to go over and see why the motor tripped, there is a temptation to put a screwdriver in that hole and tweak it up to 5 amps to stop, quote, the nuisance trips. That's a very bad thing to do. And I'd like to explain why. These two curves help show the relationship, the direct linear relationship between amp drawn, current drawn, measured in amps, current drawn, and horsepower. So on the left graph, you can see the blue line that represents full load amps. This is on 4 different powers of motorized pulley. Here we have a 7.5 horsepower, here we have a 5 horsepower motorized pulley, a 10 horsepower motorized pulley, a 15 horse, and a 20 horse. So I draw to your attention that this 20 horsepower model 400, you'll notice the 400 shows that it's a 400 model, 16 inches in diameter, 20 horsepower. It draws 23.6 full load amps when it's working at full load. Notice on the right, this is a different model, a more powerful model. It's the model 500, 20 inches in diameter, and there's a direct linear relationship between FLA and horsepower. So take a look at the 16-inch diameter horsepower, a 16-inch diameter pulley with 15 horsepower. Notice that it draws in the range of 18 to 19 amps when it's running at full load, 15 horse. This shows the relationship. Well, this shows relationship between FLA and horsepower on our model 500. This, in fact, is a 25 horsepower unit, 25 horsepower. It draws somewhere around 30 to 31 amps at full load. Now to make the point. This is 24 hours of data, which we took measuring amp draw on a 20 horsepower motorized pulley that was installed many years ago. The problem was this motor, quote, kept burning up. So we got permission to monitor the current. And as you can see, this purple line, since it's a 20 horsepower, you can see this purple line depicts 23.6 amps. That's FLA. The current should not be permitted to exceed FLA, but in actual fact, the dark blue line shows that at 6 o'clock in the morning, it exceeded 23.6 by a substantial margin for a good period of time. I don't know how much, I would say an hour, something like that. This would be no problem because it's an instantaneous rise above FLA. And here's another one that's instantaneous. But this kind of thing, which happened over the course of 1 week, told us, gave us the reason for the failures of these motors. Why did they fail? The wrong motor was installed and the overcurrent setting was adjusted. So it pains me to tell you that this operator was quote cheating and had adjusted the overcurrent protection from 24 to something like 40. And so consequently, the motors kept self-destructing. They had no way of protecting themselves. So here is a circuit diagram which shows, of course, the concept of overcurrent protection. It's very important that you protect three-phase motors from self-destructing because there is no internal way that they can protect themselves. So an overcurrent protection switch is a really important thing to put on your conveyor control circuit. This is the power circuit. These 3 solid lines are power. The light line is control. You see a variety of switches depicted here, but the ones that I'm trying to illustrate is the overcurrent protection switch. And as I said previously, we feel very strongly that if available, an internal thermal protection switch should be wired in series in a normally closed control circuit to protect that motor. We realize it's supposed to be protected with overcurrent, and thermal protection, let's call it, is an extra layer of protection, an extra safety net, if you will. Let's hit some highlights from the 6th and final segment in this seminar, in this semester. We talked about, in that part of the semester, we had 7 topics, each of which had its own video. exposed versus internally powered drives. There was one video talking about food processing shaft seals that have been developed to resist infiltration and so forth. And we had 2 videos on changing oil, 1 video on maintaining regreasable labs. We'll talk about those. And there were 2 other videos calculating energy efficiency and calculating skirt board drag. And we won't have time in this webinar to talk about it, but I really want to point out to those of you who are interested in the topic of energy efficiency or power savings, take a look at that. That's 7 minutes well spent. It'll show you how to calculate a reduction in the kilowatt hours. On the left, you see bulk handling bulk handling motorized pulley. It happens to be a Model 320. And on the right is a typical food processing motorized pulley. This one happens to be 5.5 inches in diameter. In both cases, we recommend to change the oil, to inspect the oil level, to check the level. You would put the oil holes at the 4 o'clock and the 10 o'clock position. Of course, the pulley can be rotated, if you will, but if you fix it in such a way that the oil plugs can be located at 4 o'clock and 10 o'clock positions, you can put either a piece of wood or a piece of cardboard in the bottom hole like a dipstick and verify that oil is just at the bottom of the bottom hole. That's a quick and dirty way of making sure you have enough oil in the pulley. Likewise, you do exactly the same thing in the smaller diameter. If your operation does tribology and you want to inspect the oil, it's a simple matter of sucking the oil out of the hole. Once the holes are put to 4 o'clock and 10 o'clock position, simply put the syringe in the hole and extract what you need to test it. Of course, there are a variety of other ways of checking oil beyond tribology, but that's one of them. For the sake of time, I'm going to press on to talk about shaft seals, which of course is a maintenance item. On the left, you see our standard shaft seals. It's a cross-section of a Model 800, and it illustrates the fact that our inner shaft seals consist of, our inner shaft seals consist of Viton material, and the outer shaft seals are made with a nitrile product. The Viton shaft seals, we switched over to that about 10 years ago because Viton is better able to withstand higher pressure than the nitrile one is. Also higher heat. Viton can handle higher heat. On the right, you see a cross section of a mounting bracket with the lifting lug, the terminal box, but the yellow area shows what you might call the grease chamber. This happens to be one of our double labyrinth seals, and we recommend that the labyrinth seals be purged as frequently as necessary depending upon the environment. That could be as often as, say, every 30 days, purging it every 30 days to 90 days, depending upon the volume of bulk material that's being handled. And as it says in the video, I'll say right now, don't buy a regreasable labyrinth seal if you're not going to purge it, because it's worse than the standard sealing system. An unpurged labyrinth seal is more problematic than a non-maintained standard shaft seal, because the grease can actually hold any dust that would come through the labs and press it against in this case, the nitrile seal, and cause premature wear. So if you invest in a labyrinth seal system in some bulk application, be sure to purge it. And we, of course, sell grease canisters to make that as easy as possible. And that concludes, that's almost to the minute. We were shooting for 50 minutes. It's 48 minutes past 3. So I would like to open the floor now, both to Steve and to Brian, so that you can maybe share with the group any questions that came through that you think are worth sharing.
And so, Mike, thanks for that. We have just had one question come through, so you must have done a really good job explaining.
It's
yourself.
a gift.
It was regarding the amount of horsepower that we have available in our products, and Our products basically go from fractional horsepower up to 330 horsepower available in our what we call 1000 HD. So that's a 40-inch diameter product, and we can run up to 330 horsepower in that product line.
But I want to add really quickly something that many people might not notice. We frequently recommend to our customers that they use multiple drives on a conveyor system. So just because we're limited to 330 horsepower does not mean that the conveyor must require 330 horsepower or less. By installing multiple drives, we can drive conveyors in excess of what Brian just mentioned. And I won't drag on for half an hour because you can watch the appropriate video. In fact, it's called the Rulmeca Advantage, and many of you may have already seen it. But the Rulmeca Advantage, the second half, we have a quarry owner and operator in Pennsylvania mentioned the fact that he originally sent to us an inquiry, this must be 10 years ago, for a 300 horsepower motorized pulley at a certain speed. And we said, please, sir, consider two 150 horsepower motorized pulleys at a different speed. And we had a couple of meetings in Pennsylvania, a couple of video conferences and so forth. And they trusted us, decided to trust us. And they decreased their belt tension from, and I'm not exaggerating, they decreased their belt tension from 27,000 pounds to 17,000 pounds to move 1,000 tons per hour up a 1,000-foot conveyor, up a rise of 300 feet. So by going to multiple drives, we can offer beyond the horsepower that Brian just mentioned. But sometimes it's very prudent to use more than one drive on a conveyor because you can derive good technical advantages, such as the case I just mentioned, a reduction in total tension. Therefore, a less expensive belt, therefore, a belt that lasts longer. So that was a long answer to a short question. I want to mention quickly, put a little plug in for the webinar that is scheduled for December the 9th. That's another Wednesday. We'll have it at the same time of day in the afternoon to be as convenient as we can to people around the world. That will address the topics that are covered in our second semester. And our second semester has about 5 hours worth of 4 or 5 hours worth of videos that can be viewed. All of this, of course, is free. Just use the hyperlinks that have been provided to you all. You can look at those videos. You can answer the quizzes. And the second semester is more technical than the first semester, less commercial, more technical. And we'll be talking about things such as how to design a hopper feeder conveyor. This is our second most popular video. Those videos have been viewed probably around something like 3,000 or 4,000 times each, compared to the basic one on packages that has been viewed 30,000 times. So we're going to be talking about hopper feeder drives. We're also going to be talking about calculating belt cleaner drag and skirt seal drag. So it will be technical in nature. And we're also going to spend time helping anyone who attends the webinar to understand how to install, maintain, and troubleshoot Rulmeca motorized pulleys. So I encourage you to look at those videos, take the quizzes, participate with us. I promise you that we will spend the time to help you make sure that your time is well spent. So the next meeting will be December the 9th. You have between now and then to watch the videos on our YouTube channel, take the quizzes, and if everything else fails, give us a call. If you're hung up on something and you want something to be clarified, we will be delighted to spend time with you either via email or on the telephone or in a video conference. We do tons of Teams meetings nowadays. We still aren't out visiting customers as we had been previously because of the COVID safety restrictions that our customers have in place. But we definitely want to make ourselves available online via video, telephone, email, whatever you want. So if we don't have any other questions, then I'm going to close the meeting at this point. Unless Steve or Brian had any concluding comments, I welcome them if you have any concluding comments.
And so one thing that was just asked was whether there's any objections to periodic offline motor circuit analysis to monitor the electrical health of the drive. And we would say we would encourage that to do, a periodic meg-ohm test or something like that to gauge overall motor health. We think that's a good thing, and certainly monitoring even in real time, monitoring current, monitoring external temperature, monitoring vibration. We can help our customers do that. There's technology available that we can point you in the right direction for things like that. That we basically consider that predictive maintenance for our product. The preventative maintenance is pretty simple with the oil changes and seal changes, but predictive maintenance is something that we strongly recommend, and we can help with that too.
Right, and since we have a couple of minutes left, I'll mention the fact that that guy in Pennsylvania who decided to go with a dual drive system also decided to do load sharing using VFDs. And we recommended our go-to guy, an expert with VFDs who happens to sell them, but also can tune them and troubleshoot them and so forth. So he took advantage of this gentleman, and a question came up months after the installation about how the motorized pulleys were performing. This is a true story. I got a phone call in Wilmington via cell phone from the quarry in Pennsylvania with a question. So I contacted the guy in Evansville, Indiana about amp draw. He said, wait a minute, let me check. And he verified the amp draw remotely from Evansville, Indiana, told me about it in Wilmington, and I clarified via cell phone to the guy in Pennsylvania that all was well. So that's kind of a long-winded way of explaining that remote amp monitoring is now possible. It's not a big deal, can be done. In this particular case, it was a good quality VFD. And that's something that we would be interested in helping our customers with, if you have any questions on that topic. One other thing didn't come up in the seminar, but we also are willing and able to install RTDs on our motors in case you would like to do temperature monitoring. That's not a big deal for us. An RTD is a resistance temperature device, which converts resistance to, it's a way of telling what the temperature is. So we convert the resistance into degrees Fahrenheit. We can let folks know what the motorized pulley is doing, how hot it is. We did a very hot application at a processing plant in Chicago, and so we installed the RTDs, and it's a very nice way of monitoring a motor's performance and verifying real time that all is well when you can't see anything from the outside. It's nice to be able to take a peek at what's happening inside. And strip charts are available and data loggers are available. That's all low bucks. It's not a lot of money to put something like that on your motor. And we'd be delighted to help customers with that. Any other concluding thoughts?
It looks like that's it. I think we're good.
All right, ladies and gentlemen, I want to thank you for spending 1 hour with us, listening to us talk about what we love. This is a product that's fun to sell because it is a problem solver, not a name only, but in reality. And we could talk your ears off on all of the problems we've solved, but we tried to stay on topic. So thank you for listening to this. And once again, I'll say once more in closing that I encourage you to take a look at those videos in our second semester and answer those quizzes and submit them. It's all automatic on Microsoft Forms. And we'll take a look at what you answer to prepare ourselves for our next get-together, which will be December the 9th at 3 o'clock Eastern Time. So with that, I'm going to end the conference. Thanks once again. We appreciate you spending time with us. Have a great day and stay safe.